The industry of the future is calling, and we're answering. With truly open automation to fuel the next generation of efficient, resilient operations. With practices that protect our planet and empower the ones bringing tomorrow's industry to life today. The industry of the future is open. Are you in? Life is on.
Industrial automation has lived a steady life for past decades. Yet we are in a world changing at exponential rate. Good proof of that is the past year, where we have witnessed huge demand rising up for everything remote. How will the automation systems keep up with this change? This is Innovation Day and Industrial Automation Stream. I'm your host, Harri Rajaniemi, and I have some great conversations lined up for today for you. First, we'll have Valeriy Vyatkin, professor from Aalto University, distinguished expert in universal automation, giving us a keynote on something called IEC61499 and how that is expected to change the landscape of industrial automation in the near future. Joining us for the latter half of the hour are two additional experts in industrial automation, Mr. Veli-Matti Järvinen from Metso Outotec. Veli-Matti is an automation all-rounder. He's been working in different companies, different roles, and knows the subject inside out. And then we have John Conway from Schneider Electric, bringing in our expertise on the roundtable discussion on universal automation. Without further ado, let's watch a quick video on Valeriy and continue there.
Hello, very good morning. My name is Valeriy Vyatkin. I'm Professor of Information Technologies in Industrial Automation at Aalto University, School of Electrical Engineering. And today I'm going to talk about IEC61499. That is an upcoming standard for universal automation. So here you can see our research group of IT and automation. Actually, it's a small part of the group, and the reason that a small part is it's very hard to keep these guys in one room. They are always somewhere presenting, visiting companies, doing projects, and one another reason is that they got very cool and expensive toys, like these ones that you see in our lab, which is called Aalto Factory of the Future. Since we belong to electrical engineering school, we are very focused in our interests of what we understand as technologies enabling factory of the future. These are IT, IoT, artificial intelligence, and advanced communication. So we have a private 5G access point in our lab, and we use cobots put on mobile platforms to experiment with extreme flexibility. So that's what we see as enablers of future industry. And as you can see in our lab, we have different examples of modular equipment to play with different crazy scenarios of highly mobile, highly agile production processes and human involved in them. We also have obviously cloud connectivity and IoT integration into the production process. And as this video shows, we implemented an experimental assembly process that has a physical layout changing during the operation, and this is done for the sake of flexibility. So on the same production line, we demonstrate that we can produce different products, changing production orders, and have nano PLCs automating it, all communicating wirelessly one with another. So just that was a brief introduction into our group. And then we come to the topic, what is IEC61499? And I would like to just introduce it on example. So suppose that you want to automate a simple process system like this vessel, which can maintain level of some liquid and heat it to a certain temperature and maybe cook some products in it. And you have an infrastructure of heterogeneous automation devices, which could be also a PLC, small controllers, motor drives, smart valves, smart pumps, and so on and so forth. So they all connected with wired and wireless networks. So how you go about this automation? Of course, in the center there is a software. So you want to design component software diagram that would cover all the functionalities of the system. And in IEC 61499, it's represented as such component diagram where components communicate via message passing, and then you add description of your heterogeneous hardware world and you map one to another, and you tell software components in which hardware devices they will live. So this is one main magic of IEC 61499. With one click, you deploy it, and using a software tool, you can communicate with those devices, configure them, deploy the code, even though the devices may come from different vendors. Another thing you may want is to buy software component from another vendor who has created it with a different tool. And you port in, let's say, a PID controller from another vendor, and that is also supported by 61499. And finally, what you want is also those devices on the network interoperate one with another. So this combination of configurability, portability, and interoperability, plus the component diagram language that gives you system level model is in a nutshell IEC 61499. So this combination of technologies plus so the open provisions of openness, such as open management protocol for devices and open storage in XML form for your program artifacts. So underneath of these possibilities, there is a message passing mechanism between components, also called event-driven execution. Basically, function blocks, which are components, they in 61499 send messages to each other like nodes in computer networks. So this software concept is fit very well to network deployment of your block diagrams, and makes it independent in execution from internal cycles of PLCs. So it gives you possibility to describe the overall functionality of your system independently from underlying hardware. What problems does IEC 61499 solve? So it provides you system level architecture that is capable of describing the entire functionality of automation system, provides reuse, reconfiguration, and advanced validation possibilities, enables portability, interoperability, and configurability, and one-click distribution of code to multiple controllers, which means that probably that's a path to the holy grail of automatic software generation based on physical layouts of our systems. So a little bit about history of IEC61499. There is a global research and development network around this concept for about maybe 20 years. And it started with a small group of companies in Europe and America about the year 2000. And already by the year 2005, it included Finland on the map of 61499 related research. For example, in 2006, there was a seminar at Aalto University with Finnish industry investigating potential of 61499 for process automation. Also, 2005 was the first commercial implementation of 61499 by Isograph. And now we have a really big global network that includes all continents and actively researching and doing different pilots. There have been, through these years, dozens and dozens of pilot projects, kind of enhancing 61499 and testing it in various environments. I just want to quickly run you through a couple of pilots where I have been involved or know a little bit about this. Like, let me start with my past work about a decade ago on baggage handling systems automation. When I worked at the University of Auckland, we collaborated with baggage handling automation companies that develop such systems. And when we analyzed, we understood that the systems are highly modular and kind of ready for IoT architecture because of the natural modularity. You see, like motors and conveyor sections are quite self-contained. Therefore, the wish of companies which produce, like OEMs producing equipment for baggage handling systems, is to commoditize it and make it sort of commodity products, conveyor sections with embedded control. So that we, for implementing this vision, we developed a multi-agent approach to the automation, where every conveyor section is represented as a piece of action, as a piece of activity. And this architecture enabled us doing such thing as taking the layout of a typical small automation system of baggage handling, the layout of a physical conveyor in the baggage handling system, and generating program in IEC61499 where all function blocks in the program actually are identical, but they play different roles dependent on their physical location. And altogether, we've proven that this distributed architecture is capable of implementing all the features of traditional baggage handling automation system, which are quite sophisticated features. And then we also deployed it to the network of 50 controllers to measure networking performance and communication performance, and also made sure that it's more than enough, more than sufficient with the current technology to implement it in the field. Another interesting example, it's a current work, it's ongoing work, championed by Open Process Automation Framework. That is a big organization that is led by end users such as ExxonMobil. And ExxonMobil has built a test bed in Texas, which has about 200 controllers connected to a simulated plant and fully programmed in IEC61499. You can see the structure of this test bed with a heterogeneous network of devices from different vendors, all powered with IEC61499 platform of Schneider Electric, the software runtime, And within that work, it was a very interesting experiment conducted on kind of semantic level interoperability of software components. When engineers of ExxonMobil provided the control schema that is implemented using block diagram 61499 with the roles identified for different parts of control and measurement. And they distributed these block interfaces to different developers from different companies. So they developed to the provided interface, they developed the functionality and supplied these blocks, and they were assembled and ran almost without any debugging needed, just put together, plugged, and worked as expected. So we at Aalto University have been trying to reproduce this experiment on a smaller scale. So we have a smaller scale set up in the lab, for which we extensively use in different projects, and for which we have also a very sophisticated digital twin. So we took a part thereof and developed a block diagram solution using IEC61499. Then we experimented with this idea of semantic interoperability, taking the control cascade of two PID controllers and like playing all possible combinations of two available PID controllers as if they were coming from different vendors. So we put the cascade from like 1, 1, 1, 2, 2, 1, 2, 2. So all possible combinations, and tested that they work out of the box. We also implemented here a batch control with a recipe controller. In 61499, you implement such things using state machine language, encapsulated into a function block. Then this function block network also implements functionality of 3 smart sensors. You see like 3 function blocks which are corresponding to 3 smart sensors of level and temperature, and various HMI functionalities as well, part of this function block solution. So altogether, this is a combination of different heterogeneous functionalities of classic OT, IT, such as SCADA and interaction, and IoT in one box, and we deployed it to heterogeneous network of hardware devices. Okay, another example I already mentioned is this model assembly station, which has a physically reconfigurable layout on the fly to implement different products and different orders which are coming dynamically while the other orders are being produced. The control is implemented via a network of 10 wirelessly connected 61499 compliant PLCs. So how do we build a program for this? So we start in truly object-oriented way. We have a system composed, let's say, in nutshell of 6 conveyor sections. So we fetch from library 6 instances of the same conveyor function block. There are 2 pneumatic jacks. We also fetch and put into the design space 2 function blocks implementing functionality of those jacks. And then we connect them with a material flow connection, that's information connection that corresponds to material flow. We continue with adding services on top, which are placing services and planning services. And finally, we add description of the product, like a recipe. And that's all. That's a whole function block diagram that is implementing the functionality of this flexible production system. So effectively, we have implemented this way a layered service architecture where we have 3 layers. Execution layer, a planning layer, and the recipe layer, kind of business logic layer. And finally, we deploy this function block diagram to the distributed network of controllers that are embedded into physical mechatronic objects. So that's, in a nutshell, the design using 61499 function blocks. So to summarize, I want to use slides of our partners from Next Control. We are currently involved in a research project on automating, where one of the pilots is automation of packaging production line, and the design of software follows the physical structure of this packaging line with one function block per one machine. So it has been proven that this design approach with IEC61499 gives an engineering time gain of about 3 to 4 times compared to existing PLC technologies. So it provides a hardware abstraction where basically software blocks represent hardware components, and you can manipulate with them freely and then deploy them to heterogeneous networks of hardware and software-based PLCs from like IoT-like small devices up to the edge-based or cloud-based platforms. And last but not least, this architecture is a direct provider and enabler of reconfigurability. So if your physical layout of the system changes, you just add one software component to your software configuration, or you substitute, if you substitute a physical component with a hardware, with another physical component, you just change one software component in the function block network. Okay, so that's in a nutshell introduction of 61499. A few words about Aalto University and 61499. We are teaching this technology for already maybe 6 years, and about 200 students every year are exposed to practical training in IEC61499, and then they do projects in our research labs. So we have experience of about 20 years involvement into the relevant research, and I have written a book on that topic, which has been through 4 editions, 3 in English and 1 in German. So you have a contact point. If you have any further questions, I would be more than happy to talk to you and participate in discussions on 61499. Thank you very much, and looking to your questions.
Valeriy, thank you very much for this keynote. A lot of information and food for thought, and we'll next jump into the roundtable discussion and bring in the 2 other gentlemen with us. Let's go through a short intro first on the gentleman that will join us for the roundtable. Hello, gentlemen. Can you hear me all right?
Hello. Yes, we can.
John, Valeriy?
Yes, we can hear you. Thank you.
And welcome to the keynote, after the keynote to this roundtable. It is very good to have you here. And without further ado, let's jump to the subject. Before we dig into the challenges of the current way of working, I would like to revisit Valeriy's keynote. You brought up a lot of different points where we are moving forward from the current way of working. But in your opinion, what is the key challenge that we have with the current approach that we have?
Well, I think software development in automation is becoming like overwhelming activity, and automation is more and more software business. And we are missing adequate technologies to manage the complexity of software development. So IEC61499 admittedly fits this gap and provides much better performance in that space.
Okay, good. Let's take a customer view on these. So jumping to Veli-Matti. Veli-Matti, what are the key challenges or biggest challenges that you face with your automation system deployments? I know that you deploy a lot, so and you are very familiar with the subject. So in your opinion, what are the key challenges for Metso Outotec at this point?
Thank you, Harri. It's a great question. And actually, there are plenty of challenges, but I could name one, which is the process value chain. So Metso Outotec is a market and thought leader in delivering processes for aggregates, minerals processing, and metals industries. So when taking this entire value chain of our customers, so we are a system integrator from a process control point of view, but when taking this entire value chain, there are many suppliers that make it complete, not only us, but many others. And when delivered, that value chain is going to develop quite heavily. So these upgrades and modernizations take place only after 1 year of commissioning of the entire plant. So the changeability and the easiness to adapt changes is critical for our customers. In addition that they need to live with the automation decision the next 30 years. So the platform is crucial, what they finally decide that they get the local support. So yeah, I could name multiple challenges in the closed systems operations, but one of the major ones is the complexity of the process and the number of different suppliers to make the entire process complete.
From talent point of view, what does it require from your people?
World would be easy when, or if there would be only one control solutions provider in the world, and we could live with one platform. Then we could have our staff trained and managed with one platform knowledge. But we are not living in this kind of world. So the customers, depending on the market area where they are located, have different preferences on process automation, which brand, which kind of support, or which existing technology the site is using. So we need to follow that preference, and we need to develop our own capability and knowledge on the preferences what our customers are having. So going into a software-based automation is most likely the future that we need to take, as we do not have the possibility and the capability on training knowledge on maybe between 5 and 10 platforms. So that is going to be impossible in the future. So we need to find a way how to overcome this.
Thank you, Veli-Matti. Let's jump to John. What Veli-Matti described there as Metso Outotec's challenges. Is there something that you, from your experience, would like to highlight as challenges our customers face with the current systems?
Well, sure. I mean, what Veli was referring to, I think, is this: we have this world of proprietary automation systems today. Okay, so that they cannot do what Valeriy described. I cannot take code from vendor X and run that software on vendor B and on vendor C. Okay, so what that means is I have to make choices, and I'm stuck with those choices for 30 years. And more importantly, I can't take perhaps software from another plant that I've developed over many years and run that on a new system because it's not portable. So, while we've been doing basic control up to PID, real-time control, which is not so simple, but I would call it basic. Now we're talking about digital twins, predictive analytics, augmented reality. Now we're talking about use cases that are becoming much more complex, that users require because they're living in a more complex world. But I have these proprietary automation systems, and so I have this gap between what I potentially can do with technology but what I can actually practically do with proprietary systems, because we all have budgets we have to respect. So we have to move to a much more efficient way of working. And as Valeriy says, it's about software. The future is about software. The new use cases is principally about software. So I have to become much more efficient in the way I engineer and develop my automation systems. And essentially my software, I have to invest it once and then be able to use it in a multi-vendor environment.
So also, I would like to highlight the aspect that Valeriy pointed out, the capabilities of people and the knowledge of people. Valeriy, you pointed out that with the 61499, the required talents are more IT related. Can you elaborate that a bit?
Well, yes. What I can tell for sure, I'm teaching IEC61499 for, I don't know, 15 years or more in different schools. And my observation is that if it's put into like uncontaminated minds of students who know nothing about PLC technology, they start actively programming in 1 week and building big systems and big projects. Even those who already have past knowledge of PLC technology, in a couple of weeks, completely retrain themselves and start building really big and challenging systems with IEC61499. So the learning path is really quick and really fits to the modern mindset of software-minded engineers. That's amazing fact. Another thing is that, of course, the current systems, they integrate a lot of different functionalities, as you mentioned, like artificial intelligence, and we want to do predictive maintenance, and we want to manage somehow people at the factory floor who are collaborating with collaborative robots, and AGVs are moving around. So that creates completely new reality where AI use for predicting different actions is a must. It's not just an option. So building such systems which combine different functionalities deployed to different devices is a new reality. And yes, I think 61499 is a backbone of technology enablers for that.
Regarding
the sorry, maybe I could just add a comment to that, to what Valeriy said, because I'm one of the old guys. I have grey hair. Okay, so
please do.
I was programming PLCs back in the early 80s. Ladder logic. I could do anything with ladder logic. I was a king of ladder logic. And today it hasn't changed so much, which is kind of the reality. The IEC61499, if you show it to an automation guy like me, I see graphical function blocks. I kind of look at it and think, yeah, okay, I understand that. You show it to an IT guy, he sees software components, objects. He understands it as well, okay? So for me, it's really an interesting technology that bridges this gap between the traditional automation and the IT worlds. And it's a technology that really brings the two together. And as Valeriy says, young guys really do get it.
Okay, so if the software is one of the key drivers, I'm wondering a bit. Valeriy has been working on the subject for past 2 decades. He's been teaching students for 6 years. Why it is now picking up speed in real life? John, do you have a take on the market drivers behind of this? What is happening? I think you mentioned some already, but could you please elaborate?
I mean, the world we're living is becoming more and more complex. I mean, the last year with COVID, okay, it's just been, people have to start doing remote working, okay, working remotely. People have to start making something else because what they're making today, no one's buying it anymore. So that's just one example. So, I mean, increasing complexity, I mean, continual pressure on cost, that just never goes away. Increased flexibility in terms of, mass customization. So that we all want to buy products that are customized to our needs. So production lines have to be much more flexible. Valeriy, a lot of the examples Valeriy was talking about, it's about modular manufacturing, be able to reconfigure lines very simply. All these, this increasing complexity, it's not going away. And the only way to solve this is software. It's new technology, it's software, it's analytics, it's artificial intelligence, it's wireless sensors. It's all about increasing technology to solve more complex problems. But I have to be able to do that in a very cost-effective way because there's no additional money. So we have to become much more efficient in the way we engineer automation systems to address these new challenges. And I think Valeriy, he talks about software components. That me is key. We talk about universal automation in Schneider. Universal automation, it's plug and produce. If I want to connect my pump to Amazon Web Services, I go get the software component, I connect it, and I'm streaming the data using a service, an IT service. I stream the data immediately using a software component. So plug and produce to be much more efficient in building applications.
If I may add a couple of words, another driver these days could be also mentioned is sustainability, which has been very widely discussed these days, and in both like ecological context, energy context. We add a new dimension to our production systems, making them energy aware and energy smart, energy adaptable. And this is just a new layer of functionality that is implemented through pure software and through interfacing with artificial intelligence and through communicating one with another in a peer-to-peer way. So it's just one example. And another dimension of sustainability is that manufacturing is moving back to traditional manufacturing countries like Europe, and that's we've heard a lot of that trend in the context of COVID pandemics. So these are just very fresh ones, which also contribute to this urge to change the technology.
I think, John, you already mentioned at some point the industrial IoT, digital twins, augmented operations, automated operations. How do these all relate to our subject today?
Well, I think these are all techniques that could help us address this, this increasingly complex world where we have to be more efficient and more productive, et cetera, et cetera. And the very simple point is, coming back to the point from Metso, it's really today to do a digital twin, I have to send real-time data to a simulation system. Okay, so I have to make a connection between my automation system and my simulation system. From whoever, from ANSYS, from Dassault System, wherever it comes from. I can do that today with any automation system. I have to do some custom programming. But I can do it, but it's quite expensive, and then it's not reproducible. So I need to go to a world where, regardless of the automation system, if I want to send data to an ANSYS simulation system, I have a software component, I plug it in, and in 5 minutes, I'm streaming data to the simulation system. And this, and I cannot do this today with these proprietary automation systems.
Okay, good. Let's jump to Veli-Matti. How many of the discussed topics is high on your list? How do you see the picture here?
Actually, all of the discussed topics are definitely on my list. Everything that we do, everything in our research and development, in our concept development, needs to contribute to the sustainability and the development of our customers' sustainability. Process automation by itself does not, well, it has a process critical function, of course. But when going into more open design and software-based automation, we actually enable the development of IoT, data analytics, digital twins, everything that can then contribute more to the sustainability that the process automation by itself. So by having more low-cost sensors, by having more data analytics, we can definitely come up with systems that create or actually develop with the continuous development process the entire operation more into sustainable direction. And that is our aim in everything that we do at Metso Outotec.
Thank you, Veli-Matti. Okay, gentlemen, I think we've covered a lot of ground regarding the challenges and partly already touching the opportunities related to universal automation. So let's jump into the next discussion topic, how we can really start solving these challenges with the universal automation. So I briefly want to revisit Valeriy's keynote, where you brought up certain things like, for example, the plug and produce. What does that actually mean?
Okay, what that means that you can, in a broader sense, you can bring together different machines, different mechatronic parts, potentially carrying on them some control and automation hardware, some communication capabilities, and you want to arrange them quickly into a working automation system. So that itself requires, solving different aspects of integration, of interoperability, of software portability, and in addition to that, you create a beast with like a lot of software components connected one with another, and the current wisdom of automation engineers: once the system is working, don't touch it. But you want to touch it and keep touching it through the whole lifetime of that, and this is inevitable. So efficient managing of this complexity through the lifetime of the system is asking for more openness. And that is what for me is plug and produce. It's broader than just one-time plug and play. It is like the same kind of possibility, but spread across the lifetime of the system.
Valeriy's keynote wasn't the first time I've heard about the plug and produce. John, we use the same term quite a bit. Is the Schneider language same as what Valeriy just described?
Yeah, no, definitely. I mean, when I talk about plug and produce, I'm thinking more of the software aspect, whereas Valeriy is going one step further and he's taking mechatronics. But for us, universal automation, it's about software-centric systems where I can take software components developed by domain experts like Metso, who have expertise in certain areas, and I can plug those components together. And a really simple example, and again, it comes back to this linking the OT and the IT worlds. I need to send data to Amazon Web Services. I have a new pump, and I want to do analytics on the pump. So I want to send data to Amazon Web Services. Today, how do I do that? Well, I get a table of registers that correspond to the pressure, the vibration, whatever it is I'm measuring in the pump. I read that into a data system, into a SCADA system. And then an engineer goes to the SCADA system and manually, sends that data then onto Amazon Web Services. Okay, so this is a chain that happens, and in the chain things can break. The data can move in the table, and it's not so it's simple, but there's traps. In this new world, I want to connect my pump to Amazon Web Services. Well, I take the Amazon Web Service software component that I've either developed myself or that I get from Amazon. and I just put my software component in my program. I link the data into the input of this software component, and then this software component, it uses what the IT guys call a microservice. It registers with Amazon, and it then streams the data to Amazon Web Services. So literally, I create a new pump. I just take the component, plug it in 5 minutes, I can stream data to Amazon Web Services. That's very efficient, okay? And that's just an example, okay? But that's an illustration of what I call plug and produce. I take proven and used software components, I plug them together to build an application, and then I stream the data, and then I run the application. Now, those software components, we could imagine in the future a market of I can buy these software components. We could imagine companies like Metso, they have their own IP encapsulated in software components that they use themselves as a supplier of process expertise. I mean, there's, it's different ways that you could use these software components, but the point is they are vendor independent, and they are true independent software components that I can use and plug together to operate.
Yeah, if I can complement on that, what we do actually at the moment is that when we do plant engineering for different plant islands or entire plants, we do the basic engineering and we simultaneously auto-generate the DCS code, and we can utilize that for different platforms and different process automation features. So in addition, also what we do is that when we have model predictive control as products, so when delivering advanced process control to our customers, we actually never visit the site with the ongoing deliveries when trying to optimize the customer's processes to economic optimum. So this is done completely remotely, and I can see that in the future we can do the same with process automation as well.
Thank you, Veli-Matti. There was a Schneider name flashing on Valeriy's slides regarding few projects. John, can you elaborate what type of projects we've done so far? We've been on this road for a while now.
Well, actually, we actually launched last year a new offer, EcoStruxure Automation Expert, which is based on the IEC61499 technology. The IEC61499 technology is actually a company that we acquired in 2017, a company called Next Control, which is an Austrian company that had built an industrial grade build time, runtime implementation of the IEC61499 standard. And that technology is now at the core of our EcoStruxure Automation Expert offer. Okay, so we launched that last year. We have a variety of field tests and projects in early stages ongoing. There's a very interesting one in Italy, which is actually called the Metso project. It's about recycling plastic using microwave technology, and that's being commissioned as we speak. And Next Control themselves have a variety of projects because they've been in operation since 2007 in both discrete and also process control applications. But this technology, we don't want to be the only ones launching this technology. We want other companies to launch systems using the IEC61499 technology. So we're pushing very strongly. We're having discussions with other companies about using the same technology, because really we do need to create this world of automation systems where software becomes portable across the different systems, so we can drive real value for the final customer.
Good. Regarding the numbers that were also presented on Valeriy's slide, have you seen or is there proof on that what was promised, the huge savings in engineering effort, etc. Have we been able to prove that those are real?
Yeah, we actually did. We actually had an independent system integrator do a study on different systems last year, in fact. and with demonstrating, I can't remember the figures on Valeriy's presentation, but it demonstrated, gains in engineering efficiency of 5 to 7 times for certain tasks. And there's a white paper. There's a white paper written about that. That is public. We can. That's publicly available if people are interested. But for me, it's engineering efficiency is one thing. To me, it's more though about because the engineering, it happens once, right? To me, the more important message is doing the more complex use cases with this plug and produce approach. So enabling more complex applications that address the real issues of throughput, efficiency, energy efficiency, etc. of our customers. That to me is the real gain of this technology.
Thanks, John. It has been a great conversation, and before we wrap up, I want to get the last word from Veli-Matti, the customer view. What do you see here that you think would be applicable to Metso Outotec? Is this something that you see beneficial for you?
Yes, thank you for the last words. It is definitely beneficial for us. In a nutshell, we are here for profitable business. So we need to deliver more value to our customers with less cost. So that, in a sense, creates more value to our stakeholders and shareholders. So definitely, there is a growth path and technological path that we need to follow in order to stay as a thought leader in the industry. So yes, definitely something that I want to keep up and keep on following in the future.
Thank you very much, Veli-Matti. Gentlemen, I think we are approaching our time limit. So it is time for me to thank you all for the good conversations and great insights on the universal automation. And so thank you and have a great day, and we'll surely discuss also in the future.
Thank you, Harri. Have a great day as well.
Thank you.
Thank you. Bye-bye.
Bye-bye.
So, to wrap up before we jump back to the main program, let's summarize quickly the key takeaways of this discussion. As I started in my opening, we talked about the future. Well, the future is here. And it is basically up to you now to decide whether or not you want to jump on this. The Finnish team here at Schneider will start deploying this launch of the offer during the second half. We have already started discussions with a few potential partners that are interested in this particular solution, and would be glad to take you on board with us on this journey. So I think there's a Innovation Hub virtual open if you want to visit before getting back to the main program. Please feel free to do so, or grab a cup of coffee. And it is time for me to thank you all. Thank you for your interest, and I hope to see you soon again. Thank you very much.